All right, beautiful people, this is Tuesday. We're going to start out with multiplying on number one. So depending upon how you multiply, you can do that in the standard algorithm, or you can use the distributed property strategy. You can also use the area model. So we have first factor, 637, expressing it expanded form, times 72, 70 plus 2, drawing lines everywhere we see a plus sign, and then we are going to multiply everything on this row by 2, and then everything on this row by 70. So 6 times 2 is 12. Count the zeros, write the zeros. 3 times 2 is 6. Count the 0, write the 0. 2 times 7 is 14. 7 times 6 is 42. Count the zeros. There are 3. Write them. 7 times 3 is 21. Count the zeros. Write the zeros. 7 times 7 is 49. Count the zeros. Write the zeros. And then we will add our partial products together. So we have 42,000 plus 2,100 plus 490, and we're going to add that row of partial products together first. 4, 4, and then we have another row of partial products, 60 and 14, 4, 7, 2, 1, and then we'll carefully line our digits up. That 16 carried the 1, 8, 5, 4. So we're looking at 45,864. Number 2, and this is where we are starting on today. Complete the table and then graph the coordinates. So starting with the origin, coordinate 0, 0. X's rule is plus 4, so the first one will be 0 plus 4, then 4 plus 4, then 8 plus 4, then 12 plus 4. Here it's 0 plus 3, which is 3, and 3 plus 3, which is 6, and then 6 plus 3, which is 9, and that would be 12. And from there we have a set of, or 4 sets of ordered pairs. So from there we would graph 4, 3. So we're starting at the origin, again, 0, 0. First we run to 4, then we jump to 3, which kind of sucks, but okay. Then we run to 8 and jump to 6, which, that would be 4, that'd be probably 5, 6, 7, 8. So, let's see, 6 would be right in the middle. And then first we run to 12, and then we need to jump to 9. So that would be about, and actually it should be about 6, my bad, and that would be about 9. And then we're running to 16, and we are jumping to 12. So this will be a little more difficult to graph because the graph is being done in 4s, and we have a set of coordinates that are not in 4s, so they're a little harder to figure out, but we made it work. All right, so number 3, we have 3 times 3, which is 9, 1 times 8, which is 8, and then of course we know this is an improper fraction, so we first one to the party, guess in the house, 8, 1, 1, and 1/8. That's what we will be looking at there. Here we are ordering these decimals from least to greatest. Of course, we know when we do this, we want to line our decimals up. So we're going to make sure we have a nice little decimal line here. So we are comparing like units. 0, 8, 9, 1, decimal 9, 2. And then anywhere we're missing digits, we can fill in with zeros, and we'll start from left to right. And so we're from greatest to least. So we're looking for the biggest. So these are all equal. So we go here. 9 is greater than all these digits, so 9 is going to be my first. And then we look here, we've got 2 7s. So 7 is next. So these are equal, so we'll move to the next digit. 9 is greater. then 8, and then of course we go back to 0. So then we would write these all in order based on how we numbered them. So 192, next would be number 2, 179, next would be number 3, 1.784, and then finally 1.089. And then from here we are on number 5. We need to add these. We add decimals, we line the digits up, drop it low, fill in zeros, and then we just add. So that's 7, 7, and 8. And here we are, these are a little more complex, so I want to write this out. Lining the decimals up. All right, and then anywhere we have a missing digit, we're going to fill in with a 0. And now we have 0 minus 2. Make sure you slow down if you're someone who struggles with remembering to subtract from 0. So we'll borrow from 9, it becomes 8. Give a 10 to the 0. 10 minus 2 is 8. 8 minus 0 is 8. And 5 minus 5 is 0. Homework for tonight is numbers 1, 2, 4, and 5.